Can you tell me? In the Snell's law, which we have written here, what is the n here? Please attempt. Do you know what's the n here?
The refractive index.
Yeah, very
Refractive
good.
index.
Very good. This is our refractive index. Now, do you know what's the refractive index is? It means how refractive index is related with speed of the wave. Do you know, have you any idea what's the see, this refractive index is also indicated by mu sometimes. In some books, it can be represented by mu also. In some book, it is represented by eta also, or n we write it, right? So, do you know the relation between the refractive index and the speed of the wave?
So is it the ratio of the speed in the medium to the ratio of the uh, speed of the
Vacuum.
wave in air or the vacuum?
So you want to say V upon C, right? Where V is the speed in medium, where V is the speed of wave in medium, and C is the speed of wave in vacuum. Would you like to say this one? No, this is incorrect. This is incorrect. You know why? You know how you can remember that this is incorrect? Do you know the refractive index of any medium? Have you remembered just any refractive index of any medium? Have you remembered this? Do you know the refractive index of glass is 1.5? Do you know the refractive index of water is 1.33? Have you gone through in your if you go through your theory part, you will observe that the refractive index of any medium is always greater than 1. So how this is possible? So this is possible when you have eta, or the refractive index is C upon V. V is always lesser. V is the speed of wave in any medium, and that will be the lesser. So you will get greater than 1. So in this manner, you can rectify your error that the refractive index should be C upon V, not V upon C. Is it okay? Now,
Yes, I understand
now
now.
I think now you can link all these things. See, first you have to take this refractive index, right? Then how you will find the refractive index? See, we have given the speed. See, in this question we have the speed. We can find speed like this. From the speed we can get refractive index. From refractive index we can get some angle theta, and like this all things going to connected. Is it okay? Now I think you are getting, yes, these all should be connected in a proper manner, right? Okay.
Yes,
Yes.
sir.
Okay.
Okay.
Now, what's the x is and what's the p is? So basically, x is what? See, we want to find x upon p. What is my x? X is this distance and p is this distance. So I think, okay, can you tell me what's the incidence angle? Let us suppose this point is, we can assume this as A. Can you tell me what's the incidence angle at the point A? Can you tell me? See, this will be your incidence angle, isn't it? This is my incidence angle, right? And this is my refractive angle, refraction angle or angle of refraction. Is it okay? You know why? Because the incidence angle
Yes.
is what? It's the angle between the incident ray or the normal. Similarly, the angle of refraction is the refracted ray and the normal. So now we can find q is what? Q is q is the distance. Yeah, q is the distance, p is the distance. So can we see this is the 90-degree? So in this lower triangle, can we find this angle I? I am indicating this as I. That's represent the incidence angle. So I want to find this one. So which trigonometrical ratio can give me this I? I think this should be given by sine of I, isn't it? When you find sine of I, what you can write? It should be P upon Q,
Uh,
isn't it?
P over Q, sir.
Very
P
good,
over Q, sir.
very nice. Now let us try to find this. Okay, let me change the color. So this is the angle of refraction r, right? This angle of refraction is r. Now I want to find this r. So which trigonometrical ratio would you like to write? So I think I should write sine of r. So what should be sine of r? It should be x upon y, isn't it? Yeah, correct.
Yes, sir.
Now we have to find x upon p. We have to find x upon p. How we can find this x upon p? Suppose this is the equation 1, this is the equation 2. So if I divide, right? So to see why I'm doing this, because I want my term x upon p. So I am dividing 1 divided by 2, right? So the 1, that is the sine r, is equals to x upon y, this, upon sine I is equals to p upon q, right? So from here we are getting sine r upon sine I. See, this will be what? I think this will be x into q upon p into y, isn't it? Now we are interested in this x upon p. So make this as a subject. So I will get sine r upon sine I into y upon q is equals to x upon p. Is it okay? Are you getting this?
Yes, sir, I understand. But
Now,
sir, how would we get rid of the y
yeah,
and
yeah,
q?
we will see. We will see. See, this is a big question. So we are connecting all the things in a proper manner, right? So see the options. According to options, now I want some values. I have these, relations, but now I will try to find the values. So for the value part, you have only one hint. For the value part, we have only one thing. We have to explore from this information or from this graph. Okay, let us try to understand what it is. So this is saying that the wave travel at a speed v in medium j. So we get that, okay, there is no speed mentioned here. Okay, okay. So okay, that's another tricky point here. That's another tricky point here. It's a very conceptual question. See, you can see that there is no value mentioned on the y-axis, isn't it? Right? But we are interested in the ratio of speed. See, first get the complexity of the question. What's the complexity we are facing? See, there is nothing mentioned on the y-axis for the speed. There is no numerical data we have. In the x-axis for the time we have the numerical data, but for the speed, for the y-axis, we do not have any numerical value. Are you getting this? But still this question can be solved. How? See, see here, for the refractive index or for anything, we are interested in the ratio, right? So suppose, see, this is for the medium j and this is for the medium k, right? See, the wave travels at a speed v in medium j. The graph shows how the speed of the wave varies at time t as it travels a distance q and y. Yeah, very good. So it means at t equals to 2 millisecond, my wave is traveling in the medium k, is going in the medium k. Is it okay?
Yes, sir.
Okay. One more thing we have to check the horizontal. Okay, see, this line is very important. The graph shows how the speed of the wave varies with time t as it travel a distance q. It means, speed time graph. The area of speed time graph gives us the distance, right? So basically, this much. not this much. Yeah, this much. The area of the speed time graph gives us what? It gives us the distance. Are you getting my point?
Yes, sir.
Okay. So this is the for the medium J. Now see, 1, 2, 3, 4, 5. This V is 5. 5 block. So see, this 5 block is representing V, isn't it? See, count it. 1, 2, 3, 4, 5. This 5 block is treated is counting as V. So one block is how much? One block should be V upon 5, isn't it? So it means in the medium K we have the speed of V upon 5. Can we take this? Yeah, please tell. Can we take this?
Yes, sir.
Can we take this V upon 5 as a speed in the medium K?
Yes, sir.
Yeah, very good. Now try to apply our Snell's law. What's the Snell's law is? It is n1 sine theta 1 is equals to n2 sine theta 2. And we know what's the n1 is. N1 should be C upon V. So what's the V? It's a V already, right? We have treated the speed V in medium J into sine theta 1, and theta 1, in place of theta 1 I am marking this angle I. That should be equals to n2. N2 is what? C upon V upon 5, isn't it? We got that the speed of the sound in another medium is V upon 5, and I should write here sine of R, isn't it? See what can happen. See, this C and C can be cancelled out, so we can write 1 upon V sine I is equals to 5 upon V sine R, right? This V and V can also be cancelled out, so we can find 1 upon 5 is equals to sine R upon sine I. Is it okay till here? Is it okay?
Yes, sir.
So see, the first term we
Yes,
get
sir. It's okay.
sine R upon sine I. We get that this is 1 upon 5. Now, I have to find now the ratio of Y upon Q. Now, let us see what's the Y and what's the Q. Y is what? Okay, Y and Q. This this curved sorry, this slant line. This Q and this is Y. Now, how we can find the ratio of Y upon Q? Okay, see, it's again very simple. Q is what? Q is the distance. Q is the distance traveled by this sound wave in medium J. So the distance is equals to speed into time. We know this very easy formula. So how much speed is in the medium J? The speed is V. So we should write V. And how much time it has taken in medium J? It has taken 2 millisecond. Are you getting this? It has taken 2 millisecond in the medium J. So
Yes,
this
sir.
distance should be 2 milliseconds, and this should be our Q. Is it okay? Now, similarly, if
Yes, sir.
we want
Okay.
to find the length Y, so what is the Y? So Y should be again speed into time. How much speed? So in the medium K, the speed is V upon 5. So I should write V upon 5. And how much time it has taken? It has taken, see, the
One
wave leaves
millisecond.
medium at 2.75. So how much time it has taken in medium 2? Can you tell me? See, it has entered at 2 second, 2
Uh,
millisecond, and it leaves at 2.75 millisecond, isn't it? So how much time it remains in that
yes.
medium? Only 0.75 millisecond, isn't it?
So, 0.7.
Yeah.
Yes, sir.
So this should be 0.75 millisecond. And we are interested in ratio as Y upon Q. So let us try to find Y upon Q. So what is my Y? It is V upon 5 times 0.75 millisecond. I am writing with unit so that we can get idea that should we change the unit or not. So this is V into 2 milliseconds. See, this millisecond cancel out. Whatever the unit of V, that will be the here also, so there will be no unit problem. So this v and v can be cancel out. So now we have 5 into 0.75 upon 2. Are you getting this? So please find it from the calculator, how much it is, how much it is.
So 1.875.
1.875. Okay, so I think we should, okay, please, 1.875. Yeah, please put it and get your answer. Please find it.